Good day, everybody. How are you all? Today we are going to talk about confidence interval for the mean, and we will use calculator to do it. So I'll share my screen with you. Says, suppose pizza delivery time is normally distributed with a standard deviation of 6 minutes. From a sample of 28 pizza deliveries, it was found that the sample mean time was 38 minutes. Find the 90% confidence interval for the pizza delivery time. Okay, so solution. My sample mean is 38. My sample size n is 28, which is less than 30. My sea level is 0.9, and my population standard deviation is 6. Okay. Now, although the sample size n is less than 30, but the sample came from a normal distribution. Hence, we can use the confidence interval formula with sigma equal to 6, that is population standard deviation, known. Standard deviation is known. Population standard deviation known. That formula for 90% confidence interval for the population mean is x bar plus minus z alpha by 2 times sigma divided by square root of n. Now, this whole term z alpha by 2 times sigma divided by square root of n is known as margin of error, which is often indicated by the symbol E. Some books also call this bound they call it error bound for the margin. So I'll clear that. Margin of error, which is equivalent to, some other books call it error bound for the margin. So, and it is important to note sigma by square root of n is equal to standard deviation of the sampling distribution of x bar. Sampling distribution. So standard deviation of sampling distribution, which is same as probability distribution of x bar. Distribution of x bar. The sigma by square root of n is also known as standard error. Do I have to know all this? Yeah, it's important to know these things. So now I have to define what is Z alpha by 2. So Z alpha by 2 is called the critical value of Z. Critical value of Z. What is alpha? Alpha is 1 minus C, where C is confidence level. So basically, alpha is the complement or opposite of C. So this alpha is called uh, significance level. Okay. And in our case, alpha is 1 minus C, 0.9 is 0.1. Okay. So alpha is 0.1. Now let me create some space. Oops, sorry. I have to erase this. No problem. There's this. Then this. Move. Nope, the same problem. I just wanted to move this. Okay, why? Because you see some well. Okay, so let me do the draw the standard normal distribution. Standard normal distribution. Okay, what is it? It's a bell-shaped curve basically. Okay, Z on the horizontal axis. Z is your standard normal variable. Standard normal variable. And Z is given by X minus mu by sigma, standard number. So at the center where the peak is the highest, Z is 0. Okay, so the center of the curve, that is the mean, is equal to 0. So this is the standard normal curve. Standard normal curve. Now my level of confidence is 0.9. That is the area in the center. This area is C is equal to 0.9. So area in two tails is 1 minus C, 1 minus 0.9 is equal to 0.1. So alpha, significance level, is 0.1. Because of symmetry in the standard normal curve means the left half is equal to the right half. Symmetry in the standard normal curve. In the standard normal curve, area in each tail is alpha by 2. In my case, 0.1 divided by 2 is 0.05. So this portion, this left tail, and this right tail, its area is equal to alpha by 2. And this area is also alpha by 2. And in this case, it's 0.05. Here also area is 0.05. Okay, 0.05. Now, the area, so let me erase this a little bit and make it a little bit clear. So area is alpha by 2, which I'll clear a little bit. So area is alpha by 2 in this tail, which is 0.05. Okay, so area in the left tail is left tail. Okay. Now this value of z, where we draw the vertical line to meet the standard normal curve, and area to the left is 0.05. This value of z is called minus z alpha by 2 because it's on the left of 0. And this value of z to the right of which in the area in the tail is 0.05 is called positive z alpha by 2. Why do I need to know the area on the left tail, which is half of alpha is 0.05? Because that way I can use my calculator to find the critical value of z. So, if I reduce this a little bit more, then use this. Ooh, I don't know that. Okay, not so much. A little bit bigger. Okay, and I'll get rid of this margins. Okay. Maybe, yeah. Okay, so we know the area in the left tail is 0.05, and we need to find the critical value of z. So critical value of z is in the left tail is minus z alpha by 2. How to find it? How to find it? Well, you press the calculator second key, then worst key, then scroll down to INNORM. Okay, and for area in the left tail type 0.05, mean is 0, sigma is 1. And then, so you go second, worst key is on the third row. Then scroll down to INNORM, area is 0.05, mu 0, sigma is 1, paste, enter, and enter. So minus, so, and then at the bottom you paste. Okay, when you are on paste, you hit enter and enter twice. So bottom line minus z alpha by 2 is minus 1.645. By symmetry, z alpha by 2 is without the negative sign, 1.645. Why do we need this? Because we will plug this in the formula for the confidence interval, plug this value of critical value of z or z alpha by 2. So let me move this a little bit up. So if I do that, my confidence level is 15. So maybe I should change the color. Yes. Okay. So the confidence interval is as I wrote previously, is x bar plus minus z alpha by 2 times sigma divided by square root of n. So in our case, let's move this a little bit more also. Just have to note sigma is 6 and n is 28. X bar is 38. Okay. So let me write it over here before I move it. Okay, so this is equal to x bar is 38 plus minus. Plus minus means two operations. Once we'll do the minus, next time we'll do the plus. Z alpha by 2 is 1.645 times, times I will write like this so that there is no confusion. Sigma is 6 divided by square root of sample size is 28. Remember, the sample size is less than 30, but the sample came from a normal population, so we can use this formula. Okay. So let me create some space for myself. So this will be 38 plus minus, and I will do it in one shot. How do I do it in one shot? I do 1.645 times, what is that? Don't know that. Times 6, 6 being the standard deviation, divided by, I press the second button and then the x square button in the first column to get the square root. Inside the square root, 28, and hit enter. So this term by itself is 1.865. Now this whole thing, 1.865, is, if you remember, called margin of error, or some, which is also represented by symbol E. Some books call it error bound for margin. Okay. Hence, my confidence interval, 90% confidence interval will be 38 minus 1.865, comma 38 plus 1.865. So let's crank out these two numbers with the calculator. So 38 minus 1.865 is 36.135. And then 39.865. Okay, so this is the lower boundary and this is the upper boundary. So what does it mean? With 90% confidence, we can state that the actual population mean will fall. Actual population mean will fall between 36.135 and 39.865. That is the meaning of the 90% confidence interval. Now the same thing can be done with the calculator. So then I'll show you how to do it by the calculator. So, so calculator, with calculator. Since the sample came from a normal population, use Z interval. Even though n is equal to 28. Okay, so we go stat button, then highlight test on the top row, and then scroll down to Z interval. Z interval. So stat button, and then highlight test on the top row, scroll down to the Z interval and hit enter. Okay. So first line, input should be on stats. So put the cursor on stats and hit enter so that it's flashing on stats. Okay. Now the first thing you will put is sigma. Okay. So sigma, remember, is 6. Then X bar is 38. Okay. Okay. Then N is 28. So N after this is 28. And C level, confidence level, is 0.9. And then we will calculate. Calculate. So put the cursor on calculate and hit enter. Okay. And you will get the same answer as before. The lower boundary is 36.135 and the upper boundary is 39.865. So with 90% confidence, we can state that the actual population mean will fall between 36.135 and 39.865. So I will stop here today. If you have any question or comment, please write me a note. I'll get back to you as soon as possible. And if you like this video, please give me a thumbs up. And if you like this video, please share it with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. I'll come back next time with another interesting problem, interesting solution. Take care. Have a nice day. See you next time.